very happy today. I heard it's creepy. Okay, ladies and gentlemen, so here we go. All right, 6.4. Remember last day we did this where we tried to solve these rational expressions, and all I told you was it's exactly the same as what we did the previous day with adding, subtracting rational expressions. Find the common denominator, make the terms the same, add or subtract, and guess what? We're going to do the same thing here. Okay, so let's do D together here. Okay, I'll do D and E together, and you can try F. What's the first thing I should always do when I look at rational expressions? Factor it. Even before that. Even before GCF. Yeah, step 0. It's your non-permissible values. So what are your non-permissible values for this one? Look for the denominators, and what do you see? Well, I see a denominator here with the x, so therefore I guess 2x can't be 0. You don't really need that 2 in front, so I'll just say x can't be 0. There's your NPV. Okay? A reminder, it looks like for part D, that x on the end doesn't look like a fraction. I'll rewrite it as a fraction by doing what? Over 1. Thank you. So put it over 1. And so now the question you should ask yourself is, what's the common denominator between 2, 2x, and 1? 2x. Nice. And I would suggest you rewrite all these terms with now 2x as the denominator. So go ahead and try that on your own right now, please. And don't forget to figure out what's missing from the numerator to equate these fractions. So what am I missing for the fraction on the left side of the equal sign here? And x. Thank you, Alex. And then the fraction on the right, which is the one in the middle, don't think I'm missing anything, so you can just write down a 1 if you want. If you don't want to, that's fine as well. And then the last thing with the x, I think I'm missing a factor of 2x. Okay. So go ahead now and continue trying to solve this, please. Let's try to expand out the numerators now. So I get 2x squared plus 6x all over 2x on the left-hand side. And on the right-hand side, I'll say we have 2x minus 3. Just joking. I'm glad someone's alert. What should it be then? 3x, thank you. Okay. And then over here, thank you very much, that's 2x squared. Okay, and once we get to this step where we have the denominators being the same, I told you last day we can now just go ahead and equate the numerators. So let's just make the numerators the same. And let's go ahead and solve. And I think for this one, it's nice because we actually don't have to solve a quadratic. Can you see how the 2x squared on the left and the 2x squared on the right just disappear? Because they cancel each other out. I'll move the 2x to the left side, so I get x equals negative 3. And there you have it. You are done. Okay. Now, once again, you can always double check that you're right with these because they're equations by plugging 3 back into the original and seeing if the left side then equals to the right side. All right? All right. So, did you ever wonder why cross multiplication works? I will show you with example E. Okay? Remember how before you say, oh, I see 2 fractions, they're equal, we can just cross multiply. This times this equals to this times this, right? Here's why this works. Okay? Before we do that, let's go ahead and first figure out the NPVs. Help me out, somebody, really quickly. What are the NPVs? 1/5 and also 3/5. Good. Looking at the denominators, you make them equal to 0, solve for x. Now, what is the common denominator between these 2 fractions then? What is the common denominator? 5x minus 3. Yes, Sahil, keep going. 5x minus 1. Thank you. So what I'm going to ask you to do now, please, is use the denominator of 5x minus 3 times 5x plus 1, or minus 1, and rewrite them with that as the denominator. Look what happens, dear friends, on the numerator. You have your 3x minus 5. What factor am I missing from the 3x minus 5? 5x minus 1. Okay. For the fraction on the right, I've got the 3x minus 1. What factor am I missing from there? Don't all say it at once. 5x minus 3. Yeah. Okay. Now, once again, the denominators are the same, so guess what I'm going to ask you to do now? I'm going to ask you to now equate the numerators. And what have I actually done when I do 3x minus 5 times 5x minus 1? Well, that's what this is, isn't it? The cross there. And if you look on the right-hand side, what is this 3x minus 1, 5x plus 3? Well, that's just this cross over here. There you go. That's cross multiplication, right? In a nutshell. That's why. Yes, Rebecca? Can I cross things out? Which things? Okay, well, you're saying, can I cancel like this and this? Yeah, you could, but why would you do that? Because if you do that, you're back to where you started, right? So if you like going back and forth like that, that's cool. But 10 hours later, you're still like, hey, I'm still working on this, and you're complaining Mr. Lee gives too much homework. Well, I say you did it wrong. Okay, so be careful what you're doing here. When you're simplifying, okay, Rebecca, then yes, what you did is correct. But I'm not trying to simplify. I'm trying to solve, right? Okay, so go ahead and expand this, please. 3x times 5x is 15x squared. 3x times negative 1 is negative 3x. Negative 5 times 5x is 25x. Negative 5 times 1 is positive 5. Do the same thing with the right-hand side. 15x squared. I'll do that a little bit faster. Okay. Yep. Gee, doesn't look very good when I'm making all these mistakes on the recording. Scaring you? Whatever. We all make mistakes. Just don't make them on the test. Okay, so negative 28x plus 5 on the left side, negative 14x plus 3 on the right side. You decide how you want to solve. This is nice and straightforward because you have no x squared term. So I'll say negative 14 on the left. I'll move the 5 to the right. That's negative 2. Try to please write your final answer in simplified form. I got here 1/7. Do you agree with me or disagree with me? Agree. I like it when you agree. Okay. All right, ladies and gentlemen, I'm going to ask you to try F on your own now, please. Okay. The same principles apply. By the way, what's the denominator for that x and the negative 2? If you don't see a denominator, it's just x over 1. Good. Okay. So my dear friends, please go ahead and find the NPVs first, then find the common denominators, and away you go. Okay. Okay, ladies and gentlemen, just for those of you who need a hint, NPV in this case, you look at the x plus 3, right? And it can't be equal to 0, therefore x can't be equal to negative 3. And if you're looking at the NPV, I think it's just the factor of x plus 3, which is nice. Okay. Some of you who have got this done so far, that's great. And you got to a point where you're like, I can't solve this. Remember that beautiful F word we learned? Yes, that's factoring. Right? So remember moving everything to one side. Hint, hint, hint. I'll get there in a second. Okay. But for those of you who are with me right now, I'm going to multiply the fraction on the left by the x plus 3. The one in the middle I don't need to do anything about. And then the one on the right, another x plus 3. I think then if you equate the numerators, what do you see? I think I saw many of you write this down. X squared plus 3x minus 12 equals negative 2x plus, oops, not plus, minus 6. Agree? And then some of you are stuck and you're like, I don't know what to do. Some others of you did this. You tried to move everything to one side, which I kind of liked. So I'm going to add the 2x and I'm going to add the 6. And so I think many of you had this, x squared plus 5x minus 6. What's the left side equal? Oh, what's the right side equal to, by the way? 0, yes. And then, yes, factor. Two numbers that multiply to negative 6. Those same two numbers add to 5. What could that be? Negative what? Negative 1? Positive 6. Excellent. This equals 0. You solve for x. You get x equals to 1. X equals to negative 6. Life is good. Correct? Yes. So, why do you have to find the NPVs? Turn the page and we'll find out. What a segue. Yeah. Okay, so all the questions on the first page, if you look at your answers, they're nice answers, no problems. All right. So now I'm going to ask you to try to do these questions here. Now, before we actually do the solving, once again, let's find the NPVs. Sahil, since you asked me the question, can you tell me what the NPVs are for part G here? That's right, plus or minus 2, because the x squared minus 4 can be factored into x plus 2x minus 2, right? Okay. Ladies and gentlemen, let's do this one together. So we'll continue now, and I'm going to ask yourself, what's the common denominator that we should be using in this question here? X squared minus 4, sure. Or if I'm going to write it in factored form, I'll say it's the x plus 2 along with the x minus 2. Once again, it doesn't matter if you want to use the factored form or the expanded form. Just use something that you like. Okay? I like the factored form so I can see what factors I'm missing. That's all. Right, Mavis? Okay. All right, so here's a 2, and I'm missing a factor of x minus 2 on the left. Here's an 8. I'm not missing anything in the middle. I've got the number 1, and I'm missing both of those factors, so make sure you put both of them in. And once again, I'm going to ask you to equate the numerators at this point. See if you can do some factoring, and let's see what your answers are this time. Okay. So 2x minus 4 plus an 8 equals to an x squared minus 4. I'm going to actually move all the terms to the right side just because I like having a positive x squared. That's just me. I'm a very positive kind of guy. Okay? My wife says so too. Thank you. So we've got this x squared minus 2x minus 8 equals to 0. And lovely, lovely factoring will come into play again. Anybody know what this is? Negative 4 and 2. Thank you. And then when you solve, you get x equals to 4 and x equals to negative 2. Okay? And once again, if you leave your answer like this, yes, Mavis? Why can't it be negative 2? What's wrong with this answer here? So Sahil, here's why I always ask you to find the NPVs. Remember, non-permissible values. What happens when you use one of those non-permissible values? You get division by 0, and we have no idea what that is. And looking at this algebra now, it tells you, hey, one of the solutions is your NPV. Well, wait a minute, that can't be true. This is what we call sometimes an extraneous root, meaning that the algebra makes sense, but when you go ahead and plug it back into the original question, it doesn't. Would this be a question in a test? You can answer your own questions. So therefore, for this question here, your only solution that works is x equal to 4. Okay? All right. Ladies and gentlemen, you try H, and you can try I, and you try J.
Oh, being so generous.
Okay? Well, I'll help you out too, but you know what? It's all the same stuff. With this unit, as long as you're careful, you should be fine. People just make mistakes because they multiply incorrectly, forget negative signs, all that kind of stuff. Okay, I'm going to start writing my answer now, so you go take a look at my answer when you're ready. Want to start dancing? I'll record that too. That's what I thought too. Ladies and gentlemen, for part H, the problem that many of you will encounter is when you do this minus sign with the last fraction, okay? A reminder that the minus sign applies to the entire fraction. That's why I put like a bracket around here, because this minus needs to be distributed into both of the terms in the numerator. So that's where most of you will make mistakes for this question here. Okay? If you do this properly now, what you'll find out is that you have 18 equals to 3x plus 9. We'll subtract 9 on both sides, so you get 9 equals to 3x, and then you get x equals to 3. If you leave your answer like that, without checking your NPVs, you'll be very sad. Because once again, your NPV is plus or minus 3. Your solution seems to be one of the NPVs. Oops. Therefore, extraneous. And so if I'm crossing out the only answer that I got algebraically, then what would my final solution be for this question? Yeah, so therefore there's no solution. Okay? Yes, Johnson. Yeah. Well, are you saying x equals to this? No, you're saying x can't be equal to this. Why don't you just make sure you put the cross in there? Okay? Don't be lazy. Okay, one more time. I've said this, I think, 4 times now. This is the 5th time. Looking at I believe that 3 minus x here needs to be done or needs to be changed somehow. Remember how we can change that? Remember 3 minus x, factor out the negative, switch them around, that becomes this, yes. So my advice is to do that because I always like having the x in front. Okay, and I'll show you what that means. So I'm going to rewrite this first of all like this. Okay. And by the way, for those of you who've already started the denominator on the right-hand side simplifies to x minus 3x minus 1, right? Now, once again, the nastiness of this one happens here with the 2 negatives. What can I do when I have 2 negatives like that? Just become positive. You're right. So I would suggest you try to simplify this and write this as a positive first. And then now, once you're at this stage, then go ahead and find the NPVs, then go ahead and solve all that good fun stuff that you've been doing for the last 20 minutes. Okay? You go ahead now, please, and try to solve. Help you here. Let me help unconfuse you. Okay? Common denominator, someone, tell me, please. Okay, x minus 1, x minus 3. Okay, good.
Wait, why do you have to factor out the negative one?
You don't have to. Okay, ladies and gentlemen, focus please, because this one is interesting too. Okay, so we have an x minus 3 we're missing from the first. We've got an x minus 1 we're missing from the second fraction. And the one on the right-hand side, what are we missing? Nothing. So we'll just leave it like that. Okay? Once again, equate the numerators, and I want you to simplify. So we get 2x squared minus 6x plus 4x minus 4 equals to 5x squared minus 7. And let's see what happens when you simplify. By the way, what would you want me to do? Move things to the right-hand side or move things to the left-hand side?
Right.
Okay, I'm going to go right, because once again, I'm a positive kind of guy, and I like to have positive x squared. So 3x squared, and I guess that'll be plus 2x, and then if I'm going to add 4 to both sides, negative 7 plus 4 is negative 3. Agree? All right. Factor. Oh. Choose method. 2 numbers that multiply negative 9. Those same 2 numbers add to 2. Whoever gets this right combination, I'll give you $1 million. They have to be integers, though. $1 million up for grabs. That's right. Do I have $1 million? Sorry. You'll never know. It doesn't work. So if it doesn't work, what do we do? Yeah. Quadratic equation time. Or formula, I'll say. Start to sing the song. X equals to negative b plus or minus square root of b squared minus 4ac.
I sing it on my sleeve. What?
Rebecca sings in her sleep.
Oh yeah.
Let the whole world know.
Oh no, it's being recorded. No.
4 times 3 is 12. 3, 36 over 6. This is not just for Gravillo. Okay, now, ladies and gentlemen, once again, if you can't factor, you can always use the formula. So once I've put in the numbers for the formula, I'm actually going to try to simplify this one a little bit nicer, just for those of you who like to simplify. Do you remember how to simplify root 40, dear friends? Yeah, that's the same thing as 4 times 10. That's the same thing as the square root of 4, which is 2 root 10. That's stuff from grade 10. Ah, no. Okay, so I'll give you this, and if you think that's simplified, I'll say no, 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 no. Guess what else you can do? Look at the top. Look at the numerator. What's common amongst those two terms in the numerator? The 2. So I'm going to factor out the 2, and you're left with negative 1 plus or minus root 10. And then now you can start to simplify, because now we have multiplication, and I'll say, hey, these two things can simplify to a 1 and a 3. So if you wanted the simplified form, I suggest you write it like this. Okay? There you have it. All right. Ladies and gentlemen, of course, we always save the best for last, so J will be the final one we try. It looks like there's a whole bunch of trinomials. So why don't you try this first, and then let's see what you can get. Okay, ladies and gentlemen, do not freak out, please, because look, I've got the factored form for all three of my fractions. I've got an x plus 2, an x minus 1, x plus 2, x minus 3, and an x minus 3, x minus 1. So the common denominator, unfortunately, has 3 of these factors. X plus 2, x minus 1, and also x minus 3. Okay? Intense. But don't worry, it's not going to be that bad. I mean, the properties and the idea of doing these questions is the same. How long is my test? What do you mean, how long? I don't know. I haven't made it up yet. 2 pages? Sure. To 11 and a half by 17 pages? That's great. Yeah? Okay. By the way, what factor am I missing now from the fraction on the left? X minus 3. Thank you, Betty. Hold on, I can't write that fast. X minus 1. I'm waiting. I know, there's no more. There's no more. I know. Just joking. Just joking. Okay. Equate numerators. Okay, now, dear friends, make sure when you multiply out, you don't make some stupid mistakes here, okay? So this is the stuff you learned from grade 10. I hope that that won't be your failure, because you can't actually multiply things properly. Be careful with the negative once again. I'm going to distribute the negative into both of those terms. So for those of you who wrote down plus 10, please change it to minus 10. Yep. It's up to you, but in the end, it should be the same, right? So now if we'll combine like terms together, and I'll move everything to the left side, x squared, what do we have here? That's negative 8, plus 2 is negative 6, plus 3, negative 3, plus 5, is that 2x? Negative 3, negative 6, 10, 6, 4. Is this what you have? Good. Start to factor. Can you factor? Start to factor. Can you factor? No. Quadratic formula. Once again. 4 minus 16 is negative 12. And now you're thinking, whoa, what is the deal with this square root of negative 12? You could say that this is an imaginary number. Remember that stuff from chapter 4? Or, I guess because we're dealing with what we call the real numbers, we'd say therefore there is no, and I won't just say no solution, because technically there is an imaginary solution. Yeah, no real solution. There you go. Okay. For all this work, and in the end, yes, there's no solution. What if on a test you got a question like this? Yes? If it was right, you need to show work. Show work for full marks. Okay? All right, do you want a quick 2-minute break? 30 minutes, because he's a little bit slower. That's okay, he was still pretty fast. So the question is this, okay? And by the way, this should be a change. This should be the nearest minute, not second. But the question now is the following. If we were to work together, okay? If we were to work together on this assignment, how long would it take us together? Now, I've put this little chart here to try to help you understand the context of the question. If you don't need the chart, don't use it. That's fine. Okay? Now, here's what I'm going to ask you. How long did it take me to do the assignment? 20 minutes. Okay, let's write down 20. How long did it take Mr. Louis to do the assignment? 30. Now, together, we actually don't know. So when we don't know something, we call it x. Okay, fine, x. Variable x. I was going to think t for time, but whatever. Okay, next part. Shh, quiet, please. Okay, let's focus here. The next column says this. Okay, what fraction of work can be done in 1 minute? If I finish it in 20 minutes, what fraction of the whole thing can I do in 1 minute? 1 out of 20. Good. Okay. Okay. How about Mr. Louis? 1 over 30. Okay, now what about together then? 1 over x. Awesome. Okay, now, here's the next part. Okay, what fraction of work can be done? And because you used x, I'm going to change this now to x minutes. Okay, so tell me the fraction of the work that can be done in x minutes. Not 1 minute, but x minutes. X, of course, could be 5, 10, 15, 20. So what would it be for Mr. Lee? Yeah, I heard it. 1 over 20 times x. Or you can say x over 20, right? 1/20th is 1 minute. If I do 5 minutes, that's 5 times as much. I can multiply by 5. How about Mr. Louis then? That'd be 1 over 30 times x, which is just x over 30. And how about together, if this is the case? 1 over x times x should equal to 1. Yeah. Does that make sense? The fraction of work done in x minutes, where x minutes is finishing the whole thing together. Well, finishing the whole thing is the whole thing, 1. So then I heard someone say, should we just add fractions? You're right. If this is the part that I do, and this is the part that Mr. Louis does, and that's the total, so I guess all we have to do now is just add them together. X over 20 plus x over 30 equals to 1. There you go. There's your rational expression. This one's a pretty easy one to solve, I hope. There's no NPVs at all. If you want to find the common denominator between 20 and 30, what would that be? 60, good. Please rewrite all terms with 60. X, 1. I'm missing a factor of 3. I'm missing a factor of 2. And I'm missing a factor of 60. So very simply here, I think we get 3x plus 2x equals to 60 when I equate the numerators. And this is very easy to solve. 5x equals to 60, and therefore working together, it takes us only 12 minutes. Always better to work together. Except on a test, of course. Okay. There you go. Okay. Now, another type of question that you might see is this one about the speed of a boat and all those. I know some of you saw these last year with Math 10. It's coming back again. Okay. Yeah. Physics, right. What's the relationship between distance, speed, and time? Yeah, d equals to vt. I'm going to ask you to rewrite this for time. So what would time be equal to then? Yeah, distance divided by, and I'm not going to use velocity because I'm just going to be worried about the speed. I don't worry about the direction. Okay. And so you might have seen this question before in your grade 10 notes. Okay. I just copied it here and cut and paste. But we'll try to solve it a different way. So we've got a riverboat and it moves at a rate of 18 kilometers per hour in still water. Still water meaning nothing, no waves. The boat travels upstream 85 and then travels downstream 85. So can you help me figure out the distance now upstream? That's just 85. Downstream, 85 again. Here's where it gets interesting. It says the total trip takes 10 hours, and I want you to calculate the speed of the current. So what I don't know right now is the speed of the current. Stuff you don't know in math, what do we do? Sure, let's let x equal to the speed of the current. Okay. And what happens when you go upstream? I don't know if you've been in a boat paddling upstream. Is it harder or easier to paddle upstream? Why is it harder? Because the speed of the current goes against you. So I'm going to write this down here. The current is against you when you go upstream, because that's why it's slower. And then what happens when you're going downstream? Well, the current is with you. Okay? So knowing those two things, I need you to help me write an expression for speed. What's the speed upstream? Something what? 18 minus x. Good. It's against you. It's going to slow you down. Your speed's going to be less. That's why we subtract. X plus 18 is the same as 18 plus x, but x minus 18 is not the same as 18 minus x. Downstream, yes, you're with, so you have to add. Now, once again, this is the chapter on rational expression. So where is my rational expression? Look at the time. How do I describe time? Time is equal to distance divided by speed. And I'm going to ask you to write the time in terms of distance and speed. And this hopefully is helpful for you now because I can now use that final piece of information. The total trip takes 10 hours. So I guess the time upstream and the time downstream should be equal to how much? 10 hours. So ladies and gentlemen, I think you're almost at a point where you can do the algebra now. On the test, can I give you the chart? Why not you just draw the chart yourself? That's too hard. Oh. Gee, if that's too hard, then we've got other issues here that we need to deal with. Once again, we've got other issues to deal with here. Okay. Go ahead now and find the common denominator. Okay. Okay, we'll finish solving this one, and I'll finish the back page next day, okay? Because I'm probably running out of time. But my dear friends, may I strongly suggest you work on the problems assigned in the homework. If you need help, remember there's the math clinic tomorrow after school. If you want to see me, lunchtime is probably best, or in the morning, I guess. What's 85 times 18? 1530. Okay, thank you. So just go ahead and now it's just algebra, so I hope this part's straightforward for most of you. 85 times 18 is another 1530. This time it's plus 85x. And then on the right-hand side, I've got 18 squared. That's 324. That's a difference of squares. So that's minus x squared. Isn't it nice how like, math now puts everything together? It's like, wow, all that stuff you learned before. 1530 plus 1530, 3060. Don't go yet. Okay. 3240 minus 10x squared. What's 3060 minus 3240? Help somebody. Can someone help me out by subtracting 3? Is it 180? So negative 180 equals to negative 10x squared. That's good. So x squared equals to 18. So what's x? Plus or minus root 18. And let me predict what that is. 4 point something. 4.24. Can someone check that for me? Root 18. Root 18. 4.24. That's my prediction. Okay. Now, once again, dear friends, this is a word problem. Negative speed? No, I don't understand that, so forget that. And I'll just say the speed of the current, in this case, is approximately 4.24 kilometers per hour. Okay? So I'll tell you what, dear friends, on Friday when you come back, I'll finish off the back page. We'll do a review period, get you all set up, ready to go for your Chapter 6 tests.